Okay, I'll start probably by sharing my screen for a bit. I guess you can see, hopefully.
Yes.
So I guess for this tutorial, you'll need probably best to connect to one of the cloud machines, and probably you'll want to follow this tutorial. Sorry. Yeah, so first of all, about what is on the fly domain adaptation and why it's maybe relevant. So I guess typically when we train machine translation systems, we soon notice that they are, if good, then only good for some narrow domain, which closely corresponds to the training data. So if you're training machine translation system on data that comes from European Parliament, then it will probably be good only for that type of data. But if you'll start training, translating, let's say, open subtitles type of text, then we'll soon realize that the translations are not of great quality. And for that reason, we use domain adaptation methods. That is, if we have sufficient amounts of data, we try to adapt general models to narrower domains. And typically, at least in our company, a business case is when a bigger company or agency or some government body comes and asks us to create a machine translation system for them. They give us some data, then we tailor machine translation specifically for that data and for their needs. But that means that very often smaller businesses or smaller projects are left with general domain systems just because they don't have pre-existing data sets that we can use to train their models. So for that reason, on the fly domain adaptation, or as previously proposed by these kind of people from 2017, they basically suggested that we could do instance-based domain adaptation, which is every time we have a sentence being translated, we look somewhere in the translation memory and look for similar sentences. And if we find something useful that is lexically similar to the sentence being translated, then we use those sentences to adapt our machine translation model, and we run sort of like few steps of training, and then use this adapted model to translate the sentence. When that's done, we reset the model to the original one, and that sort of gives us improved translation quality. So I guess that gives sufficient motivation for this method. And specifically in this tutorial, we will look at one scenario which sort of closely mimics day-to-day work of professional translators, where they are given a project and then they start translating this project sentence by sentence. And if we assume that there's no data to learn from, then at best we can have is every time this professional translator makes a post-edit and corrects machine translation system, we'd at least like that machine translation system was taking these edits into account. So then in this scenario, we imagine that we could ask professional translator to send back these post edits to the machine translation system, which then in return would store these original sentences and post edited translations in translation memory. And as in the scenario described before, they would be reused to improve machine translation system, so it doesn't make the same mistakes, hopefully, when translating the subsequent sentences. So, and this is basically something we did in user-focused Marian project. We basically developed some additional functionality and adapted some existing functionality in Marian, so to enable this sort of on-the-fly domain adaptation or dynamic learning, or call you whatever you like, but this sort of instant-based learning. I guess Rihards now could share his screen and continue with the hands-on part of the tutorial.
Yeah, sure. Okay, hopefully you can see my screen. Oh, no, not just yet. Okay, how about now? Hopefully you're seeing my screen now, right?
Yep.
Okay. So yeah, I'll continue with the hands-on part of the tutorial. The link to this README file, which is basically what we're going to follow here, we've made it available in the Slack channel for this talk, which is called On the Fly Domain Adaptation with dashes in between them. You should be able to find it in Slack, and hopefully somebody has shared it in the chat here, or Toms could do it.
I did it. I did it
okay.
already.
Okay then. Well, naturally we'll have some software dependencies we'll want to install here first. We have already, well, basically the things that we will use here is Marian, the neural machine translation framework you've been you're becoming familiar in these talks already, I think, which with the on-the-fly domain adaptation capability, and we'll be running it as a web service. Also, we're using Lucene underneath for translation as a translation memory. Well, basically, Lucene is the thing that's storing the previously saved sentences that are then passed to Marian to adapt translations to train for some little number of iterations and improve the model on the fly. So the sentences are being stored there. There's also a web service that glues both of these things together. So there's a web service that retrieves similar sentences from Lucene, from the translation memory, and then passes them to Marian along with the translation. Well, I mean, no, not the translation, but the sentence that you want to translate, passes these as contexts, a bunch of context sentences, and Marian uses them to adapt the model. So both of these things are managed by the web service described in the third item, and yeah.
Sorry, Richard, can you please zoom in a little bit or increase the font?
Okay, sure. I'll do it some more. Okay, is it better now?
Maybe a little bit more. Yeah, I think.
Okay, yeah, sorry.
Thanks.
Okay. So, and then there are some other tools that we will go over that are needed for some data processing tasks and so on. So the first three items we have already set them up for the participants of the tutorial so that you don't have to do it manually. But if somebody is following the tutorial on their own hardware, or maybe watching this presentation after the event, and then you should follow the link here, which goes to the Marian examples. Goes to Marian examples GitHub repository where there are instructions for setting up the web service. That would, yeah, but yeah, as I've said, the participants of this tutorial today, you don't have to do any of this. We have already set these things up. So also on the server that the participants are using, we have already set up some tools. We have pre-installed some software, and here are also instructions for people following along either on their own hardware or at a later time. So you don't have to execute these commands if you're participating currently. Okay, well, basically these are some Python dependencies, and we'll be using virtual env to set up virtual environments. So okay, let's move on. Okay, so the first step that everybody should do now is prepare the Python environment for the software, well, for the tools that we will be using for processing data, or well, doing other stuff. But yeah, you should you should log in to your use your account on the server for this tutorial. And okay, I'll try to okay, better yet, I guess I'll just go over the first set of steps that you should be doing. I'll give you some time to do them, and afterwards I'll I'll execute these commands in the terminal, so we can see the results together if somebody doesn't want to follow along these steps, well, to execute them by themselves. So first, yeah, as I've said, create a virtual environment for Python. Then activate the environment so that you're using stuff installed in the venv folder instead of the global Python packages on the system you're running. So virtual env is nice because it allows you to install everything in the separate folder, separate from the things that are installed on the server globally, so that you don't have to have root access. You don't have to use the sudo command to install anything. So everything just will go in this folder. So this is the command you use to create it, and afterwards you activate the environment so that you're using so that you switch to using stuff in this folder, like Python and pip, and so on. So after you've done it, you should install these Python dependencies using pip install. These will come in handy later on when we will process, well, when we will be processing the data. So please do that. Afterwards, we also will need Moses decoder. So Moses is the statistical machine translation toolkit that was very widely used before the advent of neural machine translation. But there are still plenty of useful tools in there that are often used for data processing, for example. And we will be using those in the tutorial. So please use git clone to clone this official Moses decoder GitHub repository into your home folder in the Moses decoder folder. And okay, yeah, this is it for the software dependencies. So I'll give you a bit more time to execute these commands. And in the meantime, I'll try to share my screen in a different way so that I can have a terminal on the side here. I'll try to change things around here.
I think currently we can see only your browser window.
Yeah, I know. I'll try to share the screen as a whole. But can I do that? Portion of screen, no. Huh.
It's easiest to stop screen sharing and then start it again.
Okay, stop share. The issue is that I see only the individual windows here. I can select them, but
I think usually the first one is your desktop, the very first window that you see, if
okay.
I'm not mistaken.
The very first item is whiteboard here. The second one is runtime domain adaptation, which is the Firefox window I've been sharing, but I don't see an option to share the whole screen. Maybe it's different on Linux for some reason. Portion of the screen. Okay, maybe this. Okay.
Well, maybe you can assume that everybody can follow the web page and share just the common console.
Yeah, I'll have to do that. Yeah, for some reason I don't see the terminal window here either. So maybe we'll have to change things so that Dwams runs the commands. Sorry for that, but I simply don't see the option in the select window for implication in that menu. I don't see any way for me to share my console or the screen as a whole.
Yeah, well, the problem is that I would have to do it through remote desktop, so it might kill my internet.
This is unfortunate.
But are you using a Mac or a Linux?
No, I'm using a Linux. I haven't.
I have no idea about Linux, but in Mac you usually see the desktop and all the other windows.
Hmm. Well, okay, there might be a workaround. I could share my Emacs window where I can execute terminal commands, and maybe we can use that. The issue maybe is that I won't have a nice markdown preview, or maybe I can achieve that. Okay, well, I guess we'll just have to try.
I guess this is fine.
I'll just move stuff around. Okay, wait a bit. I'll try to increase the font size. Okay. Hopefully you can see my well, Emacs now. Okay, we were here. Install Python tools into virtual environment. I'll open a terminal here on the side, and hopefully I can, yeah, I can increase the size here as well. I'll SSH into the server using Tom's account, using Tom's password. Yeah, cool. Okay, great. I'm in. And okay, let's start by executing the commands here. So first, as I said, we want to create the virtual folder for the virtual environment. And we want to make sure that we're using Python 3 here. So this should do it. Yeah, we have a venv folder created here. We have it now, and now we activate the environment by typing this command. And as you can see here, we have the environment activated, and we can make sure that we're using pip from the virtual environment by executing which pip command, and see that we're using pip from the folder here. Okay, now that we have pip from the virtual env, we'll use pip install sacreblue subword empty and requests. That will take some amount of time, but yeah, we've installed the software. And okay, now the next step is to download Moses. I'll copy the URL from the left screen and okay, and that's it. We should have, now we are ready for the next steps. We have Moses installed and the virtual environment is created. So, okay, now moving on. Okay, actually, wait a sec. I could maybe create a preview for the markdown window. No, that just opens a browser window. Okay, doesn't matter. So let's go on with data preparation. So there are multiple steps that we should do before we can pass text to the translation service. So generally, these things are meant to so that we transform the text in a way that the neural machine translation model understands it. The first thing you have to do is do a git clone of the runtime domain adaptation tutorial. Well, basically the thing this README is in. I hopefully you have already done it, but I'll do it here on the tutorials server. Okay, I clone it into the tutorials directory. Oh no, something's wrong. Oh, tutorial. All right. List tutorial. Here are the contents. So in there, what you'll find is there are a bunch of files there. So there is the README we're following here along. There's a client.py file which we'll introduce a bit later. Then there's a data folder with the text we'll be translating. And there are some models as well. So now we'll proceed to pre-process the data, and the steps we'll be doing is punctuation normalization, tokenization, true casing, and byte pair encoding. Yeah, as I've said before, these steps are needed so that the text is transformed into a form that's expected by the NMT model. Before we do that, we will have to set some variables that we will use in the scripts below. So first, we want to set the source and target language code, which will be English for the source language, target, and German for the target language. Now also we have to specify the directories well, specify the directories. We downloaded the tools in like Moses decoder. Specify Moses decoder's path. Specify the path to the models, which should be in the tutorial folder we just downloaded.
Sorry, Richard, just one clarification question. So these data that we are seeing, the IT news, the EMEA, these are used by, I mean, they are going to be stored in Lucene, right? So they are the translation memories that we are talking about, correct?
Sorry, could you repeat the question?
So these files, exactly these ones that you are basically pointing, these are the sentence pairs that we will be storing in Lucene as translation memories so that we can retrieve later on, right?
No, not quite. So the tutorial will consist of taking one of them and translating them sentence by sentence, and we will basically be like simulating this scenario where after receiving translation for the first sentence, we will pretend that we post-edit this translation and send back the reference translation to the system. So that will be stored together with the initial translation request in the translation memory. And we have prepared quite few of these files because like the aim of the tutorial is not only to show how to use on the fly domain adaptation, but also to experiment with what are the characteristics of data that make it work well, and which ones are and what kind of data will affect will not work well with this technology.
Okay, thank you.
So yeah, as Tom said, basically each of the participants will pick some of these files and translate them. So if we want to translate for example, this one, the first part of the EMEA corpora we've kind of split out. We'll want to translate the English part, but we'll simulate a translator in the loop by also, well, providing the German translations. So one sentence from this will be translated. Then we will take a first sentence from this file and provide it for the translation memory. So the idea is that the translator translates a first sentence from here, but then gets he gets a translation from Marian, then post edits it, and as a post edit will take the first sentence from here and saves it to the translation memory, and then moves on to translating the second sentence from the English side. So that's what we're going to simulate.
So they are basically gradually added to the translation memory as you are continuing the translation.
Yeah, exactly.
Perfect.
Okay. Okay, we've set the models variable. Also, each of the participants will have to use a unique identifier so that the sentences they send into these shared web services we're using in the shared translation memory so that they don't clash. So, for example, my user ID is echo is something like this. These should be unique among the participants. And also, these web services that we've set up, they're hosted on the local host here on this machine. So, and they can be accessed through localhost ports 5010 through 5016. There are 7 instances. So as a kind of poor man's load balancer, we just randomize the port for each of the participants. So each of the participants should execute this command to get a random port like so. Mine is 5011. And now you should, we'll start by translating the files in the medical, from the medical data. And these are located here. We changed, well, here in data, medical. Here are a bunch of them. I'll use the first one, I guess. And what you should do is set the prefix variable to one of these files. So since I chose the first one, mine will be EMEA German and English and first. Yeah, this should do it. Okay. Now that I've chosen the file I'll translate, I'll move on to actually pre-processing the data. As I mentioned before, the first step is punctuation normalization, and generally we want to do this to kind of reduce variability in the punctuation that's encountered in the text, so that, for example, multiple spaces are turned into a single space. Some code characters are normalized, like these angle bracket quotes, maybe some apostrophe-like quotes are converted. All these are converted to a single standard form. And well, there are other classes of characters that are normalized in a similar way. So for that, we'll use the normalized punctuation.perl file, which comes from the Moses scripts Moses project we've downloaded previously. So we should execute now the punctuation normalization script like so. First, we process the source side of the corpora we've chosen. Okay, something's a bit wrong here. I'll try to. Okay, I'll try to execute this manually.
I think your Moses scripts directory is empty at the moment.
Yeah, didn't I set it up before? Apparently not. Yeah, maybe I forgot this step. So I should.
You said Moses script or Moses scripts.
Oh, there's a.
Yeah, it appears.
Okay, yeah. Now it should be fine, I hope. Let's try this again. Yes. Let's take a look into the file we've just generated. Okay, it's in the data folder, I guess. Medical. Yeah, here's the one that's not in green. This is the file we've generated. Let's take a look at it. On norm n. So I guess it's hard to see now, but I won't compare it to the original, but well, the punctuation should be normalized here now. Anyway, let's do the same thing for target. For the target side, and yeah, we have it also now.
Maybe since we have approximately 15 minutes remaining, you can carry on with the steps, and meanwhile I can roughly just go over what they are. So,
okay.
So the tokenization basically just and we're explaining quite basic things here. We're tokenizing things just to separate words and punctuation marks, such as in the example, so that we would have separate tokens as opposed to free-falling text. Then true casing basically converts the uppercased words into lowercase words in case if they are not necessarily proper nouns, but that's also depending on the language. For example, for German, I guess nouns should be left with starting capital letter. And then we apply byte pair encoding as typically we do in machine translation to ensure that we have open vocabulary as opposed to infinite fixed vocabulary. And then we should be ready to translate each of those. We should be ready to translate.
Yeah, I've executed the steps here. You should hopefully you've managed to follow along, and the files that we are going to translate are these ones, which are the BP was the final step in the process. So for translation, as I've said before, we'll connect to the web services, a web service that's hosted, that's available through the local host on the ports I've showed you earlier. And for translation, we'll use the client.py Python file, which if we had more time, maybe it would have been good to kind of go through what's happening here. But basically, the idea is we just simulate the thing I described earlier. So we go through a source file and target file and execute, well, this method, which just, goes through the sources and targets and first translates the source and then saves the it prints the translation and then it saves the source into the translation memory, so that the next time translation is invoked, it can the service on the web service underneath it is able to retrieve these saved sentences to attempt to improve the translations for future sentences. So let's now do just that. We'll invoke the client.py script and pass it the source and the target. Well, these are the files that we've just preprocessed. Okay. Warning built-in no rules for language D.
That's fine, I guess.
Yeah, that's fine. Now it will take some time to translate.
So yeah, like translation in this way takes longer than normally, just because as more sentences we translate, the more material to adapt our model we have accumulated in the translation memory. And then for some of the sentences, we actually are in the background performing runtime adaptation, which is basically an extra step of training. And this process is therefore slower, and also in the background it takes more GPU memory because the model is loaded not only for decoding but also for training. So I guess you can run the vanilla translation.
Yeah, we've just the dynamic translation is finished now. Now I'll run the regular translation as well. As you can, well, it runs. You can notice that the difference here is that, well, here we pass the source and the target file. Here we pass only source, so the target isn't specified, and the script is smart enough to not save any sentences when they aren't available. So this simulates only regular translation. And yep, now we have these two files, output dynamic.de and output regular.de. And well, now the thing we have to do is calculate the results. We'll execute SacreBlue, which calculates a blue score. And as you can see, for the dynamic translation, the blue score is 29. And for the regular translation, we have 22.9 blue. So there's roughly 6 blue points improvement here.
So I guess we won't have time to try to translate a different type of text, let's say news article. But here the point was that if we did, we would probably notice that translating news articles doesn't really become better if we use dynamic this on-the-fly domain adaptation. And the reason for that is that typically when we have a technical text, those are quite repetitive because the intention of the technical text typically is to precisely describe something or inform, and therefore they can be quite dull and monotonous. Texts that are meant for entertaining people, they typically avoid repeating the same sentences or the same phrases or same words, and they have more diverse or rich vocabulary. And for that reason, we have less opportunities to learn from the previous sentences, because each sentence has very few words repeated or few phrases repeated, and this doesn't really help. Let's say knowing how you should have translated first 10 sentences doesn't really help to translate the 11th sentence. Well, for medical texts or in general technical texts, it is the case that an example of how to translate first 10 sentences would probably help you to translate the subsequent ones. Maybe can you switch back to the web browser version of?
Yeah, I'll do that.
So as a way to measure how repetitive the text is, we actually computed the token to type ratio for all those files. And also we translated these files with both versions of translation, with the typical like normal translation and using on-the-fly domain adaptation. And then we plotted these results where on x-axis you have difference between translation quality measured in blue between the two versions of translations, and on the y-axis you have token to type ratio, where tokens are words in the sentence and types are unique words in the sentence in the document. Sorry. And you can see that with some outliers, of course, but in general, the pattern seems to be that results are better when texts tend to be more repetitive, and vice versa. And you can't see it here, but the cluster more to the left and bottom is our news articles, while the cluster more on the top and the right are texts from medical domain. And yeah, and so we also calculating when calculating correlation, we noticed that there is some strong evidence that these two variables are related. That is, text repetitiveness has an impact on how effective on-the-fly domain adaptation is. But of course, these are not the only impacting factors that can affect how well this technology works. For example, if your text that you're translating are not novel for the machine translation system, that is, if they are very similar to the training data the system was trained on, then regardless how repetitive the text is, the translation won't improve much, because the baseline will probably translate it well already. And then there's another thing that one should take into account, is that it's not only the source side of the text, but also the target side that matters. Let's say if we have some terminology that is translated in different ways on the target language, then due to this inconsistency, we won't really have any additional benefit if we try to use this data for on-the-fly domain adaptation. And maybe last but not least, translating in this fashion, while it gives improved translation quality, it also is much slower and more resource demanding. So it's not necessarily viable for domains where speed is a concern, or where we want to save resources. That's, I guess, it.
Nice. Thank you very much, guys. It was a very interesting tutorial. I think we have time for a couple of questions. I am not seeing any questions in the chat. So if anyone in the audience has any question, feel free to unmute and ask. If not, I have a question. So in that paper, I think that you have cited, the training is basically based on the similarity of the retrieved sample to the one that you are going to translate. Are we following almost a similar approach here? How we decide about the similarity and all this stuff?
Yeah. So to retrieve similar sentences, we initially use stem-based lexical similarity, basically word overlap ratio, and because it's fast. and then when we have retrieved, let's say, first, let's say 1,000 sentences, if there are that many, then we rescore them using blue as a second similarity measure, and then we, I guess, in this implementation we use not more than top 50 because of performance concerns, and yeah, we do it this way. Of course, blue might not be the best way how to rescore these sentences, especially for morphologically rich languages. But we basically followed the initial description of the method. Probably Charef would be better alternative for some languages.
Okay, thanks. Yeah, I think we are almost on time. Yeah, so thank you very much again for this presentation. Very nice one. So we will have, I think, a 1 hour break for lunch, basically, and then we will come back with the hackathon